I also we're going over 7.5 today. And it goes with the vertex. So 7.5, analyzing graphs of quadratic functions. So since it's quadratic, when we talk about quadratic, we're talking about equations that have an x squared term as their highest degree in that polynomial, which means that these graphs are going to be parabolas. Okay, and I'll explain how I get the U shape versus the upside down view, okay? So, film looks like it keeps going in and out on me. Oh, no. So first we're going to talk about the vertex of a parabola. The vertex is the minimum or maximum point on a parabola. So minimum or maximum point on a parabola. So there's two ways I can, well, one way I can really tell if this is a minimum or maximum. So if the x squared term is positive, then you're going to have a minimum. Okay, x squared term positive is going to be a minimum. And the graph will look like the U, okay? If the x squared term is negative, then we got a maximum. That negative, remember from section 7.1 or 7.2, when we put a negative in front, it flipped my graph over the x-axis. So that would cause this to be a maximum. And the graph will be upside down. All right. Two other things I can get from that vertex point. First thing, the vertex, if I split that parabola right in half, I have what we call an axis of symmetry. Or other times I'll just call it a line symmetry. But the axis of symmetry is like an imaginary line. So it's an imaginary line that basically divides that parabola. So it's going to divide the parabola into equal halves. Now, MATLAB is going to ask us for the line of symmetry or the axis of symmetry. The axis of symmetry comes in the form x equals some number a. And y'all, the a is going to equal the x value of the vertex. So when I find my vertex, I'm going to have it, it's going to look like an ordered pair. It's going to have an x value and a y value. The x value gives me that line of symmetry. The y value gives me the min or max amount. So the minimum or maximum amount is equal to the y value of the vertex. Now, to tell whether I got a minimum or maximum, I'm going to look at them x squared terms. Is it positive x squared or is it a negative x squared? Okay. That will determine the minimum or maximum. The y value will give me that amount. Okay. So we got a formula for the vertex. So next we'll look at what we call the vertex formula. So y'all, the vertex will look like an ordered pair, so it's going to be in parentheses. To get the x value of the vertex, we do the formula negative b divided by 2a. So the x squared term will give you the a, whatever number's in front of the x squared. The x in the middle will give you the b term. The number at the end will be the c. Because remember, these will be an x squared plus minus x plus minus some number. Okay? So it gives me the x value. To get my y value, I take that x value I just got and plug it back into that function. Which means we're going to find f of negative b over 2a. So that'll give me my x point right here and my y value there. Once I've got that vertex, I can knock out the line of symmetry or the axis of symmetry and then the momentum max values, okay? Hey, y'all seen that negative b over 2a? That's the first part of your quad formula, remember? It just don't have all that radical stuff. Because what that's finding is that vertex point, the x coordinate, the radical stuff adds from one side subtracts, and that's what gives you the zeros of it. So, all right, so watch this, y'all. On this problem, they want us to find the vertex, axis of symmetry, determine if it's a min or max and the value. Then it wants you to graph. Now, I probably won't physically graph them, but I'll tell y'all what I would do to graph it in MATLAB. All these to graph in MATLAB, we'll use that quadratic tool that looks like a U. Mm-hmm. But in the beginning of the class, when you did those parameters that took 3 points, now we just got to use 2. We got to use the vertex first, and then one side or the other, it'll draw that whole graph for us, okay? All right, so for this problem, they're giving us f of x is going to equal x squared minus 14x plus 40. So, notice I need to know what my A's and B's are here, so I'm just going to figure out what A, B, and C are going to equal. A will be 1, because that's a 1x squared. B will be negative 14, and C will be the positive 40. So I know what my numbers are now, I'm just going to plug them into my formulas. So I'm playing with the vertex. So let's get that x value first. To get the x value, I'm going to do negative b divided by 2a. Now y'all notice my b is a negative 14. That formula has a negative b, so you gotta write this negative down and then put in that negative 14 for the b. So what kills people is a lot of times they forget one of them negatives and it throws that answer off when it does, okay? Now, at the bottom, I got 2 times a, which is 1. I'll tell you, just like on a quad formula, that negative in front of the b, all its job is to change the sign of that b. That's its whole purpose. So up here, b was negative. Well, this negative made that a. Positive 14 over 2, which means I now know my x value is going to be 7. So now I know the x value, I need to come back and get my y value. And it tells me to find the y value, I'm going to find f of negative b over 2a. So that'll be f. So what do we get out of negative b over 2a? 7. So this is going to be f of 7. So f of 7 means take this little function right here, and for both of these x's, you're going to put me a 7 in there. So that's going to give me 7 squared minus 14 times 7 plus 40. Now, y'all, here's the cool thing about this. When you're finding the y value, when I figure out this part, what's 7 squared? Minus, this next term is always twice as big as this one. So if this was 49, this is now 14 times 7, which would be 98. And then plus my 40. Now, the signs might be opposite on these, but they're always, this one's always twice as big as this one. So I don't like that because when I'm doing this part, 49 minus 98, yeah, that's going to be a negative 49. Because it's half of that, right? So negative 49 plus 40 is going to give me a negative 9. Which is now my y value. Now, y'all watch this. When you put this in MATLAB on the vertex, you got to put it in parentheses. Put your 7 for the x, your negative 9 for the y. So that takes care of this vertex. So everything else should be a little nicer now that we got that vertex, okay? The axes of symmetry. Now, in MATLAB, it don't want 7. It wants this in the form of an equation. So it's going to be x equals 7. If you don't put that x equals in MATLAB, it will mark that wrong. Okay? All right, so that's our axis of symmetry. Then it says, hey, determine if you got a min or max value. So min or max. Well, to know if I got a min or max, you're going to look at this x squared term right at the very beginning. And we said there were 2 cases. It's either going to be positive or negative. Well, mine is positive. So when I had a positive x squared, I said this would be a minimum because it looks like a U shoot through there, okay? So what would be my minimum value then? It's going to be that y value, right? And my y value is negative 9. Okay, so in MATLAB, to graph this, you first got to plot that vertex point. Then you can choose whatever other point you want to plot to draw that parabola. So choose any second point to finish the graph. Okay. Now I will say this, in this section, a lot of times, you can hit this with the quadratic formula, that square plus, use the quad on that, that'll give you where it crosses the x-axis, so that'll give you another point. Put a 0 in and get you another point. You got many ways you can find the second point. Graph it on the calculator. Look at the table. That'll give you another point, okay? Any other point you can find, that's all you got to do, and then graph it, okay? They're not too bad once you get on there. All right, y'all, for the next example, I'm going to do this one for sure. It's got fraction on it, and some of y'all don't like fractions all the time, so here we go. So I got 2x squared plus 10x plus 15. So I'm going to figure out my A, B, and C again. A is 2, B will be 10, and C will be 15. I'm going to do the same thing I did here. I'm going to find my x value, then my y value to get that vertex. So the x value is negative b divided by 2a. So I put my negative, b is a 10 this time, and then 2 times a, which is a 2. So y'all, at this point, I'm looking at this and I'm sort of sad, because I know a negative 10 will not divide nicely by 4. So negative 10 ain't divided by 4 gives me a nice number. It's going to end up being a fraction. So the only thing I can do to that really is reduce my fraction down. So both of them will divide by 2. So since they both divide by 2, I'm going to make that a negative 5 over 2. That's my x value. So sadly, we got to find the f of that negative 5 halves to get that y value. Which means you got to take that function and put a negative 5 halves in for both of those x's, okay? So your function is 2 times negative 5 halves squared plus 10 times the negative 5 halves plus 15. Now I'm going to lie, you put that on a calculator and it'll spit out these answers quick. Don't care how I'll do this by hand though. By hand, I'm going to start with that exponent. You got to do exponents before you can multiply and add and all that fun stuff. So the exponent applies to the negative 5 halves. So when you got a fraction to an exponent, you square both of those numbers. So negative 5 times negative 5, give me a 25 on top. And then 2 times 2 on the bottom will give me, what, a 4? And then I'm just bringing everything else down. So all we did was square that negative 5 halves on that step. Now it looks like I can do all my multiplying. So to multiply, I'm going to put 1s under these numbers that don't have a bottom. So multiply fractions straight across, top times top, bottom times bottom. So y'all, the first one I got 2 times 25 gives me 50 over 1 times 4 is 4. In the middle, a positive times a negative is going to make that a negative. And what we got on top, 10 times 5 is 50 over 1 times 2 is 2. And then it's plus that 15. So now probably the hardest part is adding these fractions. So what I'm going to do is put me a 1 under the 15 to make it look like a fraction. So hell, to add a fraction, I need one thing. I need a common denominator. So between a 4, a 2, and a 1, what's your common denominator? It's got to be the 4. So my goal is to turn all fractions to have a 4 on the bottom, okay? Well, that's good, right? So bring it down. 50 over 4 does not have to change. But that second fraction has a 2 on the bottom. What are you going to do to a 2 to turn it into a 4? And guess what? You multiply that bottom times 2, you got to multiply the top by 2. So let's see, that'll be minus 100 over 4. But y'all look at that. At this point, is that one not double this one? So once you get to the simplified state, you'll notice stuff like that. Now, the 15 has a 1 on the bottom. What you multiply that by? 4. So I'm going to do that to the top and bottom by 4. So that's going to be, what, a 60 over 4. So we change the way they look. We don't change the value they have. The 60 divided by 4 is still 15 at that end, okay? All right, so here we go. 50 minus 100 is a negative 50. Negative 50 plus 60 is a 10. Negative 50 plus my 60. So 10 over 4. But all your adding stuff is done on top, and then you slide that common denominator over. Now, can you simplify that one? What did you just say? 5 over 2. So we now have our vertex, which is a negative 5 halves, and then a positive 5 halves. Okay. Now I have seen people putting it in as decimal form, negative 2.5, positive 2.5, and it's been working. Okay. So if it don't specifically say that it's got to be a fraction, you can usually do it either way. So that was A, that's my vertex. How about my axis of symmetry? So remember, that's got to be an equation. So it's going to be x equals something. Negative 5 halves, because that's the x value, right? That's how I always remember that. Hey, they want the line of the x. So it's got to be the x point, right? All right, so here's the next question. Do I have a minimum or maximum? Good job, because this x squared term is a positive 2. Anytime it's positive, you got a minimum. Negative is when it flips over and makes it a maximum. Well, what's the minimum value? 5 halves. It's the y value. Good job. And notice how you put these answers in. Line of symmetry's got to have the x. Min or max, just the number. Okay.
Is that the rest of that problem?
Yeah. So once I found this vertex right here, I was able to use it for these two answers. So the hard work is finding me a vertex. Once you got it, it's not that bad because you just got to remember where to put them. And then graphing this one, start with the vertex. On this one, the graph would be broken into halves because it's got those 5 halves and stuff. And if you don't like graphing fractions, turn them into decimals. Y'all know where 2.5 is. It's between 2 and 3, right? 3.5, 4, 4.55. Going by halves if you use decimals. Probably easier than doing 5 halves. Because 5 halves, what that means is if your graph is broken into halves, you go to 5 of them. Or negative 5 of them. So anyway on that, okay? All right, let's go, new problem. But no, these got like 3 or 4 parts on these, so that's why they look longer, because you're having to do all the extra stuff, the symmetry and the min and max stuff. All right, y'all, this one has a f of x equals negative x squared minus 4x plus 2. So I'm gonna go through figure out A, B, and C again. I know A is now a -1. B is a -4, and C is a +2. Also, Roscoe, this one was a little longer looking because of these fractions I had to work with. I had to add fractions as a hassle. Like this one, if I get nice integers, we can add them and be done really quick. Don't have to worry about common denominators and all that fun stuff. All right, y'all, let's get the x value. We're going to do negative b over 2a. So write your negative. Uh-oh, this time b is a -4. So that's going to give me 2 negatives right there. And then on the bottom, 2 times a, which is a -1. Now, here's the trick on that. You got 3 negatives on that. What sign will this answer be?
Negative.
Negative. Because odd number of negatives keeps it negative, even number makes it positive, okay? So since I had 3 negatives, I know this is going to stay negative. And then I got basically 4 over 2. So that's going to be what, a -2. So no ugly fractions this time, okay? Now we want to find the y value. To find the y value, I'm going to find f of that -2. And this to me is really almost like if you was graphing this function, you would find x values and then plug them in and get the y values when you make your little tables up. It's just that this was requiring us to use the vertex for the x to get the y's, which is basically the same principle, okay? So f of -2, now here's where I get people. That negative is in this formula, so write it no matter what. Now you're plugging in for the y, which is a -2. So I'm going to put my -2 in parentheses and square it. Now, there's probably one rule I always do. If I'm putting in a negative number for x, it's going in parentheses. If you don't put them in parentheses on the calculator, it don't square the negatives like you need, and it gives you wrong answers. So when you square negative numbers, put them in parentheses, okay? Then we got -4 times -2 plus 2. So watch this. I'm going to bring this negative down because you cannot do a negative times a negative in this case and make that a positive yet. So bring that negative down. Priority goes to the exponent. So before I can multiply by that negative out front, I got to figure out what is -2 squared. +4. So do you see what happens? This ain't going to be a positive number, is it? It's going to stay negative. Okay. Now right here, -4 times -2, we make that what, a +8. And then at the end is my +2. At this point, 8 is twice as big as that 4 again. That's almost one way I check myself, you know. It's always got to be double the first one. They might have opposite signs, but it's going to be double. So I know -4 plus 8 is 4. And then 4 plus 2, 6. So I got my vertex now, y'all. It's going to be -2 and a +6. So next I needed to know my axis of symmetry. So let's see, axis of symmetry for this one is going to be x equals some number. So let's see, when I get from my x, I got a -2. So the line of symmetry is x equals -2. Next, on this one, do I have a min or max?
Max. Max.
I heard it. Maximum you saying on there?
Yes, max.
Yeah, you're perfect, because right here, pi x squared is negative, so it's definitely a maximum. So keep it on the road. What's the maximum value? And that's
6.
definitely,
6,
Okay.
like she said.
and then graphing that, and start with that vertex, and then do one side or the other, okay? All right, so now I'm gonna do some true or false with y'all. So to answer these questions, hopefully you did section 7.2 already. 7.2 is where we shifted the graphs left and right, up and down, and we flipped them and did all that fun stuff. But here we go for true or false, okay? Okay, here we go. The function f of x equals 6x squared plus 6x plus 1 has a maximum value. Y'all, is that true or false?
False. Okay.
So why would you say false?
There's no negative.
It's false because the 6x squared is a positive.
It's positive, perfect, both of y'all. This thing is positive, so this thing actually has a minimum.
Minimum. Yeah.
You're actually paying attention to me sometimes. That's a good job, right?
So the problem is they have negative in there is.
And definitely a minimum. And then if it has like a negative like this one did, just want to flip it over and make it a maximum, okay? All right, so let me try one more true or false, and then I'll move on. All righty. The graph h of x equals x plus 2 squared can be obtained by translating the graph h of x equals x squared right 2 units. So is that true or false? The graph of h of x equals x plus 2 squared can be obtained by translating the graph h of x equals x squared right 2 units. So on your horizontal movement, when they added 2, did that move me right or did that move me left? Oh, you say that? Who said that? It is definitely left, right?
Yeah.
Because remember, on the horizontal, it moves opposite what you're saying.
Right.
X plus 2 would bring it right, but actually it brings it left.
Well,
Which means this question is false. Good job. So you'll just have a few true and false like that. All right, let me see. Okay, I got time for my good ones. So I'm gonna. So I got plenty of time still, so here we go. Get some of these harder ones out of the way. And they're not really that they're harder to work. They just ask one more question. That's the range stuff. Okay. And usually y'all don't like range too much. So here we go. On this problem, I'm going to find vertex. min or max value. And find that value, and then I'm gonna find the range. And then I'm gonna find intervals, increasing and decreasing. So really the new thing, we don't do a lot of range in the beginning, and we really haven't done much on this increasing and decreasing. But I will say this, when you're looking at increasing and decreasing, read that graph left to right. Because usually the x-axis is time, and we always go to the right for our time, we don't go backwards, okay? So first, let me put the equation. They're giving me f of x equals x squared minus 10x plus 24. But really, y'all, on this problem, although they're asking me a lot of extra stuff, that vertex point we find is going to give me all I need, okay? So first, let's find the vertex. So I'm going to find the x value and then the y value, okay? So once again, x is negative b divided by 2a. So that's going to be a negative, b is a negative 10 sitting in the middle. And then it's 2 times my a, which is 1.
Why don't you do anything with the x squared?
Oh, because we're just wanting the numbers in front of the x squared. Because what's going to happen when you do the vertex form, it's just going to give you the x coordinate and the y coordinate. And we only use the x squared when we're evaluating it to get that y coordinate. Okay?
You don't plug it into that negative b over 2a.
No, you're just using, just like on the quad, you just put the numbers in only. We just want to know what's in the placeholder of the x squared to be my a. What's in the placeholder of the x term, which is my b, and then what's that constant term at the end, which is always that number. Okay? And one thing that's very important on these, we don't mess them up in this section, but make sure they're in the right order when you first start. X squared, x number, okay? I don't think we was cruel and put them out of order in this section, but some of them sections in the future, when we do factoring and quad stuff, they might be out of order, okay? All right, so that's what, 10 over 2. So I know my x value is now A5, which means I know my axis of symmetry is x equals 5, okay? And I know my intervals will center on that 5 when we hit that point, okay? So now we want the y value, which is going to be f of 5. Now, right now, I'm worried about the x squareds because I'm plugging these 5s in for the x squareds. So here, when I put a 5 in, I'm going to get a 5 squared minus 10 times the x, which is a 5 plus 24. Okay? It's just when they made the formulas, we didn't have to worry about the variables. All right, y'all, 5 squared is 25. Which means I don't even got to look at these numbers. If that's 25, I know this is automatically going to be 50. And then plus my 24. So let's see. 25 minus 50 is a negative 25. Negative 25 plus 24. Negative 1. So here's my vertex. I get a 5, negative 1. I'll tell you all a little trick too. I put a program in that calculator that does this vertex stuff. I think I did. Look and see it down the bottom of y'all. It'll be the last program in there that says vertex.
How do we find?
Program button member. And then arrow down. Past quad and go down a little bit.
You say program? Oh, program.
Uh-huh. Everything I give you is gonna be in the program button in that middle part, so
Oh, I see birthday.
hit enter twice. And then put in your numbers. So it should have a question mark, it didn't put the A there, so that'll be a 1 enter. Then you'll put a -10 enter, and then a 24 enter.
Okay, so we do one enter.
Yeah, you already hit enter. Now enter one more time to get it started. So now put in the numbers like we put, like we're doing this one here. So put in a 1, -10, and then a 10, 24. Oh, I know what's in it. Oh, okay, so watch this. Arrow back, and well, let's delete this. So what's first number? Where you at? So 1, enter. Now the B is -10, enter. And then the C, 24.
I need to put the negatives outside there.
So when you do that, you should get what I got right here. 5, -1.
I got negative 5, but, y'all need to put that.
You must have put the sign in wrong.
Oh, yeah, something I did.
Give me. Oh, yours is on something else. So let me quit that. So the second quit. Now do program. Arrow up that way for text enter. Yeah. Now they put in a 1, enter -10.
What we doing? Okay, well, that's what's inside the. Okay, that's what I did.
And then C was the 24.
That's 24.
So you're only on the formula, on the program, you're only putting in these numbers here.
Okay.
And it should give you that back there.
So don't worry, don't do that negative. Just put the numbers at the inside, like those on the top.
Oh, now. Yeah, don't worry about this stuff, only these numbers.
Those numbers.
Mhm.
Okay.
Because this would have meant A was 1, B would have been -10, C would have been 24. All right, next, min or maximum value.
It would be. Value.
Min or maximum value, what y'all say?
Minimum,
So I'm getting the maximum, and what are y'all saying online?
minimum,
Minimum, because remember that x squared term is
Okay, so it
positive,
depends only on the x squared term.
only on the x squared
Okay.
term. So that was positive, so definitely a minimum. What's the minimum amount? -1. All right, y'all, the range is the y values that this graph is covering. So let me just draw you what the graph is going to look like. Just to show you what we're looking at, okay? So I know over here at 5, so at 5, -1 is my vertex. Y'all said that was a minimum, so that means this graph goes up like this somehow. We don't care where it crosses over, we just want that point. 5, -1 is going to give me everything I need. So we're finding the range. The range is all the y values that are represented by this graph. So what's the smallest y value it can be? -1. So when you do the range, that -1 has to be in a bracket because it can equal that number, okay? So when you do the range, you're going to use brackets. When we do the intervals, they're only going to be curves. So now watch this. Here's the smallest my y's can be. So y'all, then they shoot up going towards what? Infinity. So then I'll put infinity. Infinity always has a curve. So this is telling me that my range starts at this -1, including the -1, and goes towards infinity. So what's next? Increasing and decreasing. So let's do our increasing. So the thing you got to remember, the range deals with the y values, intervals of increasing and decreasing are looking at the x values. So going left to right, where does my graph start increasing? At what X value?
3,
5,
5.
oh, 5.
Because see, right here's my 5 on the X, and at that 5, this graph is starting to go uphill.
Okay.
So it's going uphill starting at the 5. Now, we always use curves on this because that point can't be both. It can't be decreasing and increasing. So when you have that, we say, well, it's decreasing right up to the 5, and then it starts increasing right after the 5. That's why we use the curves. To include that point, we had to use the brackets, okay? So it's increasing from this 5 on the x-axis until I hit infinity positive. So there you go. All right, y'all, next we got decreasing. So decreasing, my graph is going downhill. So it started way out here where?
Infinity.
Oh, you're so close. Negative infinity. There you go. So from negative infinity, I'm cruising on my x-axis. My graph is decreasing, 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 bam, until I hit what? 5 on the x-axis. Good job. So notice, when you look at this increasing, decreasing, it's got to have that same point to be the changeover. Okay, that was what that 5 was. So whatever that vertex's x point is basically the changeover for the intervals of the increasing and the decreasing. Okay? Don't think that bad. It's just
You didn't have that on any of the other ones, did you?
not the range and increasing. That's new stuff, right? So remember, increasing, we're looking at what x values does it go up, or what x values does it go down. And it can even be constant later on. Constant means it goes straight across.
Oh, Lord.
But that'll be later in life.
So when we start the problem off, we can start by just entering the vertex.
That's all I'm losing is that.
And then we just kind of go from there with answering.
So the vertex, I got my minimum values, I got my, well, I erased it, but my line of symmetries would be what, x equals to 5.
Yes.
Anything with the x's is this, anything with the y values is. So the y values is the range and then the min and max stuff. I think I can get both of these. So let me try this one. It's the same thing. So this one, we'll find the vertex, range, min and max, intervals of increasing and decreasing. This time we've got f of x equals negative 8x squared minus 24x plus 9.
And what in that problem makes you realize that you need to do the range or increase it?
Oh, because they give to you very in instructions.
Or just ask for it?
In the very beginning, they ask for it. It'll say find the vertex, min or max value, and tell what that value is. Find the range, and then the intervals of increasing and decreasing. And this one's asking the same thing, okay? So first I'm gonna find my vertex. So remember on this one, A is negative 8, B is negative 24, C is a positive 9. So we're gonna get our x value, so negative B over 2A. That's gonna give me a negative 24 all over 2 times a negative 8. I'm making sure I got my numbers right, but this big second one you get that looks like a fraction probably. Because that's going to give me a 24 over a negative 16, which is a negative something, So the biggest number I could divide into that 8 and 16 would be an 8. So that's gonna give me a -3/2. Now the calculator, if you did that, it should have gave you something like a 1 point something, something, something.
I did, I think it'd be like 1.5.
3 halves is 1.5, pretty good. It'll take you in -1.5 form also.
Okay.
Now, I'm gonna find my y value, which means I'm finding f of a -3 halves. So I'm just gonna put my two x's are gonna turn into this -3 halves. So I got -8 times -3 halves squared minus 24 times -3 halves plus 9. I'm gonna do the exponent first, which is this -3 halves raised to the second power. So the -8's coming down. So let's see. -3 times -3 is a 9. 2 times 2 is 4. No matter what you square, it's got to become positive at that point. But I still got that -8 sitting in the front, okay? Now I'm just going to bring everybody else down. I'm now going to multiply, and I'm going to make these have ones under them when I multiply. Multiply straight across on those. So -8 times 9 is a -72/4. Negative times negative is going to make that a positive 72/2. So it's my 9. Now y'all, here's the trick. Do y'all feel like finding the common denominator? No. All these numbers will divide. 72 will divide by 4. See what I get? That'd be a negative something. -18. Well, hell, if that's a -18, I know automatically what this is going to be. It's going to be a positive 36 because it's always going to be twice this one. And guess what? 72 divided by 2, 36. So notice, every time this one will be twice as big, opposite sign than this one, okay? And then at the end, bring down that 9. So -18 plus 36 is a positive 18. 18 plus 9. Sounds good. So that my vertex is -3 halves, and then that 27. So next question. Does this have a min or max? It's a max because this thing had what, a negative x squared term on it, so that made that a max. What's the maximum value?
Would that be the x? Is the maximum value the x or the y?
The y.
That's the
I'm just switching up the order on y'all.
Okay.
So that's gonna be what, 27? You know, so I'm sort of throwing up, I just throw the curveball by changing the order. Now I'm gonna ask for the axis of symmetry, which is the so x equals, what do you say, -3 halves.
So the axis of symmetry is gonna be your x value.
X every time, just put x equals when you put it in math class, okay?
Okay.
All righty, so let's figure out what this one's doing so we can look at our range and our intervals. So that'd be -1, -2, -3. And then, whoa, I'm going up here at 27.
Oh my goodness.
So this is going all the way up to 27, okay?
Got it.
So over here at -3 halves, remember you said that was about -1.5?
Yeah.
So right here's that, and then up here at 27. And you said that was a max, so this thing should be just, I don't care where it's crossing, it's just coming down. It could be wider or skinnier. But all I needed was this point right here, because I know on the X, it's at -3/2 or -1.5, okay? So I got what I need, my range. The range always starts from the bottom and goes up. Well, y'all don't have a bottom amount on this, so where's it coming in from?
The top. Would be the top, or from infinity,
What kind?
negative.
Negative infinity. So it's gonna go from negative infinity. All the y values are covered until I hit 27. Now remember, since this is the range, 27 is included, so I'm gonna do what? Bracket.
Right.
Okay? Increase. Well, it's got a maximum, so it's increasing on the left side of the parabola and then decreasing on the right side. So it's coming in from negative infinity. My graph is increasing until I get to this x value right here, which was what, a negative 3/2. And remember, these always use curves on increasing and decreasing, okay? So remember, I looked at the y values for the range, I'm looking at the x values for the increasing and decreasing. And even if you're looking at domain, you would use those x's, okay? So knowing that, what is my decreasing?
So would your decrease be coming from the positive side? Because when we did the increase.
Well, here's your parabola going down, right?
Right.
So it starts here, and as you go down these x's, this parabola just keeps dropping. So it's starting at -3/2, and as I go towards infinity. So look at these. One of these will always have a negative infinity to the number. The other one will have a number to positive infinity. Number to positive infinity, negative infinity to the number. They're all going to have that kind of pattern on them, okay? Oh, y'all got time for my last one that y'all want to like. That little rocket. A little toy rocket. Before COVID hit, we actually had a rocket day where we went outside and shot rockets up in the air and showed y'all math equations doing that and stuff.
Let's do it.
That's pretty cool.
It's just fun.
But too much COVID got that knocked out. All right, y'all, here we go. Last problem of the day. A toy rocket is shot vertically into the air from a launching pad 7 feet above the ground. So toy rocket shot from a pad 7 feet above ground. It has an initial velocity of 96 feet per second. So initial velocity of 96 feet per second. So they give us an equation that models this information. So the equation, or how about this, the height h of the rocket is given by this formula, which says h of t. So what this means is the height depends on the time. T is time in this case. That's going to be my x variable, time. So that means time, and that means the height. Equals -16t² plus 96t plus 7. So let me show you how they got this formula. If these t's were 0, 7 would be the height above the ground, which would be 7 feet, which is what they gave me. The 96 times t is how fast it's going for how many seconds. Because they said it had a velocity of its speed of 96 feet per second. So that's where they got this part. That negative 16t squared, guess what that is? I asked y'all a while ago, didn't I? Maybe that's my other class. But when you throw something up, what force is there? Gravity. So the negative 16t squared is the gravity pulled on that rocket. So they want to know, when does the rocket reach maximum height? Then they want to know, what is the maximum height? And guess what? This negative 16t squared is my x squared term, basically. It's negative, so we do have a maximum, right? So what's going to happen, my rocket for so many seconds is going to go up. When it hits that maximum, it's going to start going back down, okay? So it looks like I need to use my buddy the vertex formula, okay? So the x coordinate for us will be the t coordinate, okay? So t will equal negative b over 2a. And then my y value with this will be the height, go to h, okay? So negative b, which is 96, so I got negative 96 over 2 times that negative 16. Now, y'all remember this. After you work this, that time better be positive. If you end up with a negative time, you did something wrong, okay? All right, so let's see. We got negative 96 divided by, looks like what I got, negative 32. Woo, might get me a good number. Because I know 96 divided by 32 is 3. Yo, that tells me my rocket reached maximum height in 3 seconds. And then the other 3 seconds was coming down. So, reaches maximum height in 3 seconds. So now what was that maximum height? That means we're finding h of 3. Now I'll tell you this, we could use that formula and we could put in any amount of seconds and it would give me the height of the rocket 1 second, 2 seconds, what's that, 4 and 5? It'll probably be on the ground after 6 apparently. It didn't take too long to hit the 3, right? Now, gravity's going to suck it back down. So to find this, we put a 3 in for these t's, okay? So I got negative 16 times 3 squared plus 96 times 3 plus 7. So remember, you want to square the exponent first. So you're going to have negative 16. 3 squared would give you 9. And then I'm just bringing everything else down. So what is a negative 16 times 9? Which means I know what this is going to be. What happens when you double 144? Well, that should be what, a positive 288. And at the end, I'm going to bring down that plus 7. All right, so here we go. Negative 144 plus 288 is a positive 144. 144 plus 7. So 151 feet. Is that pretty tall? let's say about 10 feet of floor, right, about 10 feet. So 15 stories, that's pretty good. 3 seconds, that's pretty fast. Yeah. All right, so that's the maximum height. So y'all, that was the world of the vertex.
Ooh.
So y'all have about 10 problems to do for that section. The what? Yeah, if y'all need a little help. Money ain't too bad. We're looking at radical stuff, domains of radicals. And when we do the domains of radicals, we just got to remember that you can't have negative numbers under radicals because that makes those imaginary numbers and stuff. So I'll refresh y'all on that stuff.
So when I put the vortex in, it gave me the 3 and the market you want,
Mhm.
so that's the answer. So even in.
That's all I use, ain't it?
Oh, yeah, so in math labs, like if we want to use, calculators in the vortex, we just enter the answers that they.
Yeah, math lab ain't gonna ask you for the work.
So,
It just wants that answer, right? God made technology for a
I'm
reason.
telling you.
All righty, y'all. Anyone online got any questions?
No, sir.
So that'll take us through this week. So I will see y'all Monday for a new lesson.
Okay.
Hey, y'all, hang on just 1 second. Make me make sure I got everybody on here. Mariana, let's see. All right, got Hernandez. Got Guerrero, Duggar's good, Martin's good, Cromer's good, Yolanda's good, Dijon's good. Tyler, so looks like I got all y'all, so I will see y'all Monday, okay?
Yes, sir. Have a good day.
We did 7.4, right?
Monday? Yeah, that was doing the quadratic formula stuff.